Kia ora koutou. In this video, I'm going to go through the question about the drinks cylinder volume in the Level 2 paper this year. And this is the question that I don't think should have been in Level 2. And that's because there was some differentiation in here that is pretty explicitly at curriculum level 8. So if you were doing level 3 differentiation, this would be a nice, easy optimization question. And I say easy because in here they've actually given you the formula for the surface area of a cylinder. Right? So the only tricky thing in here is that you end up differentiating a negative power, which we'll get to in a minute. Okay, so let's quickly go through the question and see that it's a pretty standard optimization setup for a level 2 problem. We've got a drinks manufacturer who is starting a new line of cylindrical cup, and they want to minimize the surface area of the new cup so that the cup stays hot for as long as possible. And the cup has a lid on it. The cup is going to hold a volume of 500 ml and it's going to be cylindrical in shape. So we have to work out the dimensions of the cylinder that would satisfy the conditions above. So just one note before I get going. Obviously, we're going to end up with a number for the radius and we're going to end up with a value for the height. And it would be, we just have to realize that 500 milliliters is the same as 500 cubic centimeters, right? So we're going to end up with our units here not being mil or anything weird like that, but centimeters. If you've done measurement at level 1, that should not feel too difficult, but I'm just sort of popping it in there now before I get into the calculus part of the problem. Okay, so as usual, we'll start by saying, what is our goal? Well, our goal is to, what are we trying to do? Minimize the surface area, and that's 2 pi r squared plus 2 pi rh. And as usual, we have a problem, right? Because we have two variables in here. And to minimize something, we want to differentiate it and set that derivative equal to 0. But we can't do that until we've got rid of either the r or the h. And in here, you can see that the r squared pops up here and r pops up here. So it's going to make sense to eliminate h. And we do that using the constraint, right? And the constraint is that the volume of the can has to be 500 ml. So we're given V is equal to pi r squared h, and that equals 500. So we're going to use this now to get rid of h. H is equal to 500 over pi r squared. We're going to take this and we're going to plonk it back into here. So cleaning all of that up, what do we get? Well, we get a new expression for the surface area. So 2 pi r squared plus 2 pi r times 500 over pi r squared, which is the same as 2 pi r squared plus 1000. Now the pi's simplify away, 1000 divided by r. And looking at how to differentiate that, we can write that as 1000 r to the power of negative 1. So those of you going on to do level 3 calculus, really early in the year, you're going to learn that differentiating fractional and negative powers works in exactly the same way. So this actually isn't difficult, it's just that most of you probably hadn't been taught that, and that's not through any fault of your teachers, right? It's pretty clear what we need to teach for level 2, and I don't believe that this is in there. I've done this with some of my classes where I've mentioned that negative and fractional powers work the same way, but I certainly haven't really hammered the point. Okay, so moving on, because this video is not just meant to be a rant about moderation processes for exams or anything like that. We have this. We have dSA by dr is equal to 4 pi r minus, so bringing down the power just like we always do, minus 1000 r, and then we're going to drop this power, and it will be r to the power of negative 2. And that has to equal 0 for a minimum or a maximum. So let's write this out now and see how we're going to solve it. We've got 4 pi r, and I'm going to make that equal to 1000 over r squared. So we've got a little cubic. I'm going to multiply both sides by r squared. I'm doing this really slowly. That gets me that. Next, we're going to have r cubed is equal to 1000 over 4 pi. When I bung that in my calculator, I get 79.57747. We take the cube root of each side, and we get r is equal to 0.30127, which is 4.30 centimetres to 2 decimal places, but I'm going to use that whole value for the next part of the calculation. So now we have h. H is equal to 500 over pi times the radius squared, and that gets me 8.60254, which you will notice is exactly double that radius, centimetres. So my dimensions are radius is 4.30 centimetres and the height is 8.60 centimetres. I really hope I've got those right. Please tell me, anyone, if you find a mistake, because I've done this pretty quickly. Now, the last thing that isn't really very clear in this question, but I'm going to do it anyway, is that it says calculate the dimensions that would satisfy the above conditions, right? So the condition is that it's got to be a minimum. So usually if we want to show that something's a minimum, we really should check that the second derivative test is met, or we can check the sign of the gradient on both sides, blah, blah, right? The fastest way here is to do a second derivative test. I haven't seen the schedule, obviously, because it's not out for ages, but I think to be safe, I'm going to pop that into this video. So let's go back to here. This is my derivative, and I need to get the second derivative. So I'm just going to move us off to the side and do it in a different color pen over here. So we get the second derivative is equal to 4 pi plus, what am I doing here? 2000 r to the negative 3, which is going to be that. Okay, so again, what I'm doing with a negative power to differentiate is I'm bringing down my power. So it's going to get multiplied in there. That's where the plus 2000 is coming from. And then I drop the power to negative 3. And you can see straight away that for our value of r, which was 4 point something, that is positive. So we've found a minimum. Okay, as I said, I don't know if you're going to need to have that. Right, so that's about it. Calculate the dimensions. Have we done everything? Yep, I think we have. So if you got through that question in the exam, well done to you. That's great. I think it's going to be a bit of a nightmare to mark this. I'm not sure how they're going to handle it, because I think a lot of students will really just not have known what to do when they got to that question. So hopefully that wasn't you. Let me know by email or leaving me a comment if there are any other questions from the papers that you really want videoed. I'm going to do the one about the noise level from, I think it's from algebra, soon for one of the Dub C students who's asked for it. So that one's coming up later on tonight.